Today we will continue with the different kinetic parameters. We said last time you have Vmax and Km, Vmax and K-catalytic. These are kinetic constants for an enzyme that you need to calculate. Now we will discuss another constant called the specificity constant, or the catalytic efficiency of an enzyme, which is the ratio K-catalytic over Km. Keep in mind, if you want to know which one is the best enzyme or couple enzyme substrate, you have to judge based on this specificity constant, which is K-catalytic on Km, and not the value of K-catalytic alone or the value of Km alone. And you will see this during the examples in a little bit. So the ratio K-catalytic over Km is called the specificity constant, or the catalytic efficiency is considered to be the criterion for a kinetic perfection. It means that we are taking into consideration the substrate specificity and the catalytic efficiency. The unit for the ratio K-catalytic over Km will be concentration minus 1 time minus 1. This ratio will measure two things. One, the enzyme substrate preference, it means the substrate specificity, and the catalytic efficiency. So these are the two parameters that we will consider or measure by calculating the ratio K-catalytic over Km. And the higher value for this ratio, the better the enzyme works with a specific substrate. So this catalytic efficiency is best defined by the ratio of K-catalytic over Km. You don't take into consideration K-catalytic alone or Km alone. This ratio has unit of a second order rate constant because it's concentration minus 1, unit minus 1, and is in general used to compare the efficiencies of different enzymes to each other. And the value of the ratio K-catalytic over Km is used to compare the use of different substrates for a particular enzyme. So which substrate is better for a specific enzyme? We may judge this by the ratio, by calculating the ratio K-catalytic over Km for each substrate. And also it's considered to be the best measure of substrate specificity and to compare efficiency, as we said previously in the slide before. So it describes the reaction of any enzyme and substrate at low substrate concentration, where the velocity of an enzyme catalyzed reaction is considered to be proportional to the substrate concentration and to the enzyme concentration. And the constant K-catalytic over Km إذا مذاكرين قبل بس عملنا calculation لل V0 قلنا it will be equal to K-catalytic over Km multiplied by S multiplied by E, and that's why we consider the constant as a second order rate equation, and the second order rate constant will be K-catalytic over Km. So كمان إذا بنقول لكم to calculate the second order rate constant directly, you have to know that we are asking you to calculate K-catalytic over Km. So it's the specificity constant, is the catalytic efficiency, is the second order rate constant for the reaction. So it will help you to rank enzymes according to how good they are with a specific substrate in case you have different substrates. So it will give you an idea which one the enzyme like most among this substrate and which one will react faster. So it will give you information about how fast the reaction for a given substrate would be when it's bound to the enzyme, and this is from K-catalytic, and how much the substrate is required to half of Vmax. يعني نحن عم نحكي عن concentration of substrate يعني هون Km. So as we said, K-catalytic over Km is collection of rate constant, لأنه نحن بنعرف إنه Km also is a collection of rate constant, and it will be K1 multiplied by K2 over K minus 1 plus K2. And if the value of K2 is much higher than K minus 1, يعني you are proceeding to product much more than going back to substrate, this will reduce the K minus 1 plus K2 to K2, and K1 multiplied by K2 over K2 will be K1. So the whole rate constant will be reduced to the value of K1. So which is E plus S to ES, يعني the rate of encounter between E and S. So كل ما كانت K2 كتير كبيرة صارت الرياكشن dependent on the interaction and the encounter of the enzyme with the substrate. These are the same, but just to keep in mind, for molecules the size of an enzyme and a typical substrate, the maximum, which is called diffusion limited K1, is between 10 times 8 to 10 times 9 molar minus 1 second minus 1. Okay, so the maximum value for K catalytic over Km for an enzyme, it will be between 10 times 8 to 10 times 9. This is very important to know. The highest value and the maximum value for a typical substrate, 10 times 8 to 10 times 9 is the value for K1, which is the same for when you have K2 very high. So the whole ratio will be limited to the value of K1, yani 10 times 8 to 10 times 1. So K1 is the sets for the upper limit for K catalytic over K1. And when you reach the upper limit, you are working under kinetic perfection. Okay, so the rate at which that enzyme active site can convert substrate to product is limiting by the rate at which it encounters the substrate in solution. And you can reach a kinetic perfection when the value of K catalytic over Km tends to the highest limit of K1 value. So you have here an example for chymotrypsin, and you have different amino acids, glycine, valine, phenylalanine, etc., and the value of K catalytic over Km. So which substrate is better for the chymotrypsin? Which amino acid chymotrypsin will prefer more? In this case, you have to look for the value of K catalytic over Km, and as you can see, phenylalanine has the highest value of K catalytic over Km, and in this case, it's the specificity. This enzyme will work better with phenylalanine than other amino acids. The same example, if you take into consideration this table where you have different enzyme and different substrate for each enzyme, the value of K catalytic and the value of Km, and the ratio K catalytic over Km, you can, so we have the enzyme, its substrate, K catalytic, Km, and the ratio. And they ask you the first question, which enzyme binds its substrate the most tightly? And here, if you have an answer, can you tell me please your answer? You can raise your hand to know which one will answer. So which among these enzymes will bind tightly, most tightly to its substrate? Fatima Zahra Fakha.
Fumarase, because the least.
Sorry, which one?
Fumarase.
Fumarase, why?
The least Km, so the highest affinity.
The lowest value of Km, so the highest affinity. صح. Next question. Which enzyme has the most rapid catalytic turnover when the enzyme is fully saturated with substrate? Emilia?
Catalase.
Why?
The highest K catalytic. So the most rapid catalytic turnover.
The highest K catalytic, so it has the rapid catalytic turnover, which is 4 10 times 7. Bravo. Now, so قلنا إنه the enzyme that will bind its substrate the most tightly is fumarase, لأنه it has the lowest value of Km. The one that it will bind, it will has the highest catalytic turnover, highest K catalytic is catalase. Now, the third question, which enzymes have the highest catalytic efficiency? Lana.
Acetylcholinesterase and fumarase, because they have the higher K catalytic over Km.
So هون شفتوا كمان هون انزيم ما حطوا لكم بلور مبينه سنجل انزيم، هون حطوا تنتبهوا بالسؤال which enzymes، لتنتبهوا انه ممكن يكون more than one. So acetylcholinesterase and fumarase. Why?
Because they have the highest K catalytic over Km.
Okay. Please note, when we asked about the enzymes that bind substrate the most tightly, ما قلنا acetylcholinesterase. صح؟ بس قلنا the enzyme has the most rapid catalytic turnover، ما قلنا acetylcholinesterase. بس عم نقول the highest catalytic efficiency ظهرت the acetylcholinesterase اللي عندها highest K catalytic over Km. So you don't judge based on Km alone or K catalytic alone. So you have to judge based on the value of K catalytic over Km. Okay? Demoiselle, are they near the limit of diffusion control? يعني are you at the catalytic perfection? Limit diffusion control يعني بس the value tends to the highest value of K1, which is equal to?
Yes, between 10 power 8 and 10 power 9.
Kinetic perfection between 10 times 8 and 10 times 9. So this is the maximum diffusion limit, which is K1. So are you working under kinetic perfection?
Yes.
Yes, because the value of the ratio K catalytic over Km tends to the highest value for kinetic perfection for K1, which is between 10 times 8 and 10 times 9. So you understand the meaning or the importance of the ratio K catalytic over Km. Now we pass to the second section now about how we can determine the value of K catalytic Km and Vmax. It's easy. So as we said, when you draw the velocity as function of S, it's a hyperbolic shape. When you have excess amount of substrate, you reach a maximum value, which is Vmax. And to determine Km, you have to calculate Vmax over 2. The interception point with the plot for x-axis is the concentration of substrate for V equal Vmax over 2 equal to Km. This is the easiest way to determine Vmax and Km. Okay. However, sometimes when you draw V as function of S, it's not satisfactory for determination of Vmax and Km. Why? Let's take this example. Sometimes when you increase the concentration of S, you may not reach the excess amount of S of the saturation concentration for S. So when you draw a plot and you reach the highest substrate concentration for your experiment here, are you able to consider the highest value as Vmax? يعني فيني أنا أقول وقف هون وأقول هيدا الفاليو corresponds to Vmax؟ برأيكم؟
No.
أكيد no. ليش؟ لأنه I have, if we increase more S, the V0 will increase to reach at high S concentration, a constant value of substrate, at a constant value for the velocity equal to this Vmax here. So manna high. If you consider this Vmax as this V0, which is wrong to do it, but if you do, Vmax over 2 will be wrong, and the value of Km will be wrong. And all the kinetic parameters that you are going to determine are wrong. So you cannot determine from this plot the value of Vmax and Km unless you really reach maximum velocity, and at least 3 consecutive value of the zero constant. When you obtain 3 for different substrate concentration, the same V0 for 3 different substrate concentration, then you can consider this V0 as Vmax. Otherwise, you cannot consider the highest value of V0 obtained for a specific substrate as the maximum velocity. Keep in mind also, so when you, نحن بنعرف إنه Michaelis-Menten equation V0 equal Vmax by S over Km plus S. So when you consider S equal to Km, you reach a velocity V0 equal to 2 over 3 Vmax. When you increase S to 3 Km, you reach 3 over 4 Vmax. You increase it to 9 Km, V0 will be 9 over 10 Vmax. To reach 100% of Vmax, انتوا بس تصير عندكم S equal 99 value of KM 99 times KM نوصل ل V0 هي 99% of the value of Vmax. يعني شوفوا قديش بدنا substrate كثير كبير in excess to reach to obtain the value of Vmax. And sometime in your experiment you don't reach such high value of substrate, but you still need to calculate Vmax and Km. So we have to look for other methods for something where you are able to determine the value of Vmax and the value of Km. So I repeat, unless after a series of experiments, you have at least 3 consistent points at this plateau where V0 is constant for 3 different substrate concentration, you will not be able to consider this velocity as Vmax. Okay? So ما فينا نرسم بلوت وقول أعلى نقطة هي Vmax وجيب Vmax over 2 وجيب منها K. And here we can see in this table, if you took the value of substrate and the value of V0 and you draw V0 as function of S, you obtain such a plot. Okay? For highest substrate concentration اللي عنا إياها هون 120 micromolar, V0 equal 45. Are you able to consider 45 units per milligram as the value of Vmax? وإذا إيه؟ كيف بدها تصير Vmax over 2؟ يعني أنا عم باخذ 22.5 يعني something above 16 يعني نقول يمكن 18 to 20 ما بعرف micromolar as the value of Km. Are you able to consider this, and are these value real value for Vmax and Km? For sure not. Okay, so we need to find other methods that will help us to determine in a more appropriate way and more correct way the value of Vmax and Km. That's why Linhofer and Burke in 1934 overcame this problem, okay, without doing any new assumptions. We are still working with Michaelis-Menten equation and Michaelis-Menten assumptions. They took the Michaelis-Menten equation, which is V0 equal Vmax by S over Km plus S, and they modify mathematically this equation to draw, instead of V as function of S, 1 over V as function of 1 over S. إذا هون بنعمل 1 over V value حتصير Km plus S over Vmax plus S. يعني عندي Km over Vmax by S plus 1 over Vmax. صار عندنا Km over Vmax multiplied by 1 over S plus 1 over Km. You obtain, if you draw 1 over V as function of 1 over S, a straight line where the slope is Km over Vmax. So this is an equation for a straight line where the slope is Km over Vmax. And for 1 over S equal to 0, 1 over V will be equal to 1 over Vmax. So the interception point with the y-axis will be the value of 1 over Vmax. And for 1 over V equal to 0, Km over Vmax multiplied by 1 over S equal to minus 1 over Vmax. Vmax and Vmax will be cancelled, and 1 over S will be equal to minus 1 over Km. And the interception point with the x-axis will be the value of minus 1 over Km. So by drawing, instead of drawing V as function of S, this hyperbolic shape of the plot, where you may not reach the value of Vmax, by drawing 1 over V as function of 1 over S, by doing an extrapolation of your plot on y-axis and x-axis, in this case, the intersection point with the y-axis will be 1 over Vmax, and the intersection point with the x-axis will be minus 1 over Km. So just you need to draw 1 over V over 1 over function as 1 over S, and you do an extrapolation for your plot, and in this case you can determine the value of 1. And
دكتور صوتك عم بيروح ويجي.
وين عم بيروح دموزيل؟
عم بخف يعني عم يوطى ويعلى الصوت فما عم نقدر نركز.
أنا صوتي بعده ثابت هو ذاته، ما بعرف إذا الكونكشن عم بتروح وتجي، بس أنا صوتي constant. consistent كمان، فإذا بدكم شيء ما سمعتوه قولوا لي لأرجع عيد.
آخر كم سطر بس بليز.
كم سطر؟
أنا اللي قلتهم
عم
هلا
بقرا
آخر شيء.
سطور، أنا عم بعمل شرح.
نو من
بحكي.
عندك يعني the last sentence 2 sentences.
اوكي ما كاتب شيء وعم حارجع اشرح اللي كنت عم بحكيه اخر سلايد. So by drawing 1 over v as function of 1 over s instead of v as function of s، واللي هي بعدنا نحن اخذين البيزك اللي هو ميكايلس مانتن equation، اوكي؟ بس عملنا لها instead v as function of s 1 over v as function of 1 over s. In this case you can do an extrapolation for this straight line اللي هي equation of a straight line 1 over v equal km over v max multiplied by 1 over s plus 1 over v max. Slope km over v max. Interception point with the y-axis is 1 over v max. With the x-axis is minus 1 over km. And in this case, you can determine km and v max graphically from this plot. Clear?
Yes, thank you.
So if we go back to the example and we said for if you draw v as function of s and you conclude that v max is equal to 45 unit per milligram and km is around half of this 22.5 يعني قلنا around 19 micromolar. If you draw 1 over v as function of 1 over s and you calculate the interception point with y-axis and x-axis, you can see that the interception point with y-axis equal 1 over 0.018. So Vmax is 55.6 unit per milligram and not 45. And minus 1 over km equal minus 0.042. So km equal to 23.8 micromolar and not 18 micromolar. So the value you obtained previously are wrong. These are the correct value. So to determine Vmax and km in a correct way, you cannot use the graph v as function of s unless you have for 3 different substrate concentration constant value of v0. Otherwise, you have to draw Linover-Burke plot, which is the double inverse plot, 1 over v as function of 1 over s, to determine the interception point between the x and y axis and deduce graphically the value of the max and km. Any question? Farah Ismail.
Yes, doctor.
Can you tell us why in which case we can determine Vmax and Km from Michaelis-Menten plot directly?
If you plot the graph 1 over v as a function of 1 over concentration of substrate.
Mademoiselle, سؤال. In which case you cannot determine Vmax and Km from Michaelis-Menten plot? Do you know what is Michaelis-Menten plot?
Yes.
What is Michaelis-Menten plot? Which one is Michaelis-Menten plot graph? Farah.
Yes, doctor. If we plot the concentration of substrate,
what is Michaelis-Menten plot? Farah.
The concentration of substrate on x-axis with the velocity on y.
Yani it's v as function of s.
Yes.
V as function of s. Y from v as function of s, in which case you should not calculate Vmax and Km from this plot, in which case you cannot.
In the case of Michaelis, we cannot calculate Km and Vmax.
All the time?
Yes. No, if it's hyperbola.
مهدي
يس دكتور.
تفضل، شو بدك تقول؟
على سؤالك، لما ما يكون معنا الفي ماكس، لما ما نكون عارفين الفي ماكس، ما بقدر اعرف من
اي متى ما عندك في ماكس؟ اما انت عم تجيب بدك تفتش عليها، يعني انت السؤال هو بده يكون تو ديترمين في ماكس، فطبيعي ما حد كيف
اوكي.
ما انت السؤال اذا بعطيك exercise بقول لك determine v max, in which case you cannot determine v max from v as function of s when you don't have what? فاطمة عطية.
كي ام.
We look at the values we have. If we don't have 3 consecutive points of highest V0 that aren't equal, then we can't determine Vmax.
It's a 3 consecutive point for 3 consecutive value for v0
For the high,
for
yeah,
different substrate concentration.
Yeah.
Okay, when for different substrate concentration you don't reach a constant value of v0, in this case you cannot use the plot v as function of s to determine Vmax and Km. Okay, وضحت فرح؟
Yes, doctor, clear.
لنا شو
يس
بدك
دكتور،
تقولي؟
أنا كنت بدي أجاوب على السؤال.
اوكي ميليا.
The same, doctor.
Okay, so everything is clear. Now let's see if this method is really optimum. In fact, Linhofer and Berg is a good method to use, and it's the mostly used method to calculate Vmax and Km. Okay, but it was criticized on several points. One, طلعوا بالصورة. نحن ليش قلنا هون ما قدرت تجيب Vmax and Km؟ لأنه ما عندي highest value for S. صح؟ When you draw 1 over V as function 1 over S, highest value of S يعني lowest value of 1 over S. يعني أنا كل ما يكون ما عندنا highest value of S يعني ما عندي lowest value of 1 over S. يعني كل هالبارت حتكون extrapolation. يعني أنا إذا معي البارت الكبيرة هي بهالاريا هون، من هون وبالنازل كله extrapolation. So it was criticized and when you don't have close value to the y-axis بصير اصعب اعمل الاكسترابوليشن sure when you have points يعني اللي منهم really straight line، يعني experimental points يمكن اوقات ما يكونوا really جايين as straight line، يعني يكون عندكم انتم different points and you need to draw your straight line between these points or you have to consider a regression line taking into consideration all these points. So in this case اذا بكره انتم عم تعملوا الاكسرسايز، اذا حطوا هلا انتم ورقه قدامكم ارسموا 1 over v 1 over s وحطوا سطر بالمسطره وعملوا له extrapolation وجربوا اذا زحتوا شوي ايدكم من هون نزلت شوي لترسموا السطر هتطلع completely another 1 over v max وها small variation بال 1 over v max بس تجيبوا v max هتعطينا variation اكبر. Okay, so this method was criticized based on this. So sometimes it gives undue weight to measurements made at low substrate concentration. لأنه at low substrate concentration أنا الفاليو اللي معي إياهم هون حيكونوا at high value for 1 over s. And then the extrapolation across 1 over v0 to determine 1 over vmax and on 1 over s to determine the value of 1 over km could be a little bit difficult, specifically when you sometimes have to you found yourself that the value of 1 over km or minus 1 over km is outside your graph paper. Okay, so هون بدنا ننتبه when we have to draw this that you need to take into consideration all these points. يعني اول شيء بدنا نرسم 1 over v function 1 over s. انتم هول الفاليو معكم اليونت معكم قديش سكيل، معنا سكيل ومعنا الفاليو. يعني انا بعرف مثلا لاقدر ارسم كل رسمتي بدي 10 سكوير، فباخذ 10 سكوير من اخر الصفحه وبحط ال1 اوفر في الواي اكسس وبترك كل المحل الباقي فراغ لانه انا عم بعرف انه عم بعمل اكسترابوليشن للبلوت على الجراف. ما فيني امسك وحط 1 اوفر في على طرف الورقه، لانه كل الاكسترابوليشن حيطلعوا برات الورقه. انا بعرف قد ايه بدي كم سكوير لارسم رسمتي، وبترك كل الباقي فراغ لحتى نرسم لنعمل الاكسترابوليشن. واكيد الميثود الاسهل انه الورقه تاخذوها بالعرض مش بالطول ليكون عندكم possibility رسم افضل. وطبيعي سكيل يكون كوريكت، ما تنقوا سكيل كثير صغير لانه ساعتها النقط بتطلع فوق بعضها، وما ننقي سكيل كثير كبير لانه بصير بدنا ورقتين وثلاثه لنقدر نجيب the value of 1 over km. So even if this method was criticized, it is the best or the mostly used to determine Vmax and km till today. Okay? Other researchers, they search other methods, but always they are based from Michaelis-Menten equation. So Eddy and Hofstee, they tried to find a relationship, not 1 over V as function 1 over S, but V as function of V over S. They found this relation. So عملوا ضربوا V bkm plus S, Vkm plus Vs equal Vmax multiplied by S, وجابوا V as function of V over S, اللي هي V equal minus Km V over S plus Vmax. وقالوا كمان straight line where the slope is minus Km, and when V over S equal to 0, V0 equal Vmax, and when V equal to 0, V over S equal Vmax over Km. And so this is a straight line كمان descending لأنه slope negative minus Km. Interception point with the y-axis is equal to Vmax, and with the x-axis أكيد عم نحكي عن extrapolation for this graph on y and x-axis will be Vmax of over Km. So if you can determine Vmax from this value, you have this value, معنى Vmax, we can determine the value of Km, أو automatically from the slope you can determine of Km. So this is another method, very used also, Eddy and Hofstee method, to determine the value of Vmax and Km graphically. فهمتوا هالاثنين؟ لينوفر اند بيرك بنسميها دبل انفرس بلوت، ادي اند هوفستي. فهمتوا هالاثنين methods؟ حدا عنده سؤال regarding these two methods؟ Okay. We pass now to a third method proposed by Hans and Wolf. Hans and Wolf أخذوا انطلقوا مش من V as function of S من Michaelis-Menten، بس أخذوا equation of Eddy Hofstee اللي هي 1 over V as function of 1 over S وضربوها ب S. صار عندهم S over V equal to S over Vmax plus Km over Vmax. وبس رسموا S over V as function of S طلع عندهم slope 1 over Vmax, and for S equal to 0, S over V equal Km over Vmax, and for S over V equal to 0 تطلع عنا S over Vmax equal minus Km over Vmax يعني S equal minus Km. And in this case هتطلع عنا شيء كثير شبيه بإدي and Hofstee plot, the double inverse plot، بس هون عم بيرسموا S over V as function of S. Extrapolation on y-axis will give you the value of Km over Vmax, and extrapolation on the x-axis will be directly the value of minus Km. So it's also a third method to calculate Vmax and Km graphically. Fourth method, it's Cornish-Bowden, the Einstein and Cornish-Bowden plot, which is an easy method but a little bit more complicated, but it's very easy based on a plot V as function of minus S. وهون عم ناخذ couple of value V and S. شو يعني؟ يعني انتم بتقولوا نحن قلنا عندنا تيبل احنا اللي اذا بناخذ هيدا عندنا تيبل اللي هن V و S، V10 S5 V12.7 S7 etc. فشو بنجي بنرسم؟ نرسم couple for V1 قديش الماينس S تاعيته the negative part. اوكي؟ نقطة هون ونقطة هون وبنرسمهم straight line. V2 قد ايه minus S2 ونرسم straight line. V3 minus S3 وبنرسم straight line. Intersection point with all these straight lines that you are going to draw will give you the value of Vmax and AM on the y-axis and the x-axis respectively. وين مشكلتها هالميثودز؟ إنه sometimes you don't have just one interception point. مثل هيدا الاكزامبل هون حيطلع عنا interception point وواحد ثاني. So the mean of these two will give you Vmax and the mean of these two value Km1 Km2 حيعطينا Km. لحديت هلا it's easy. اوكي بس اذا بتصير اصعب when you have 3 interception point وهون بنكون فتنا بميثود اصعب ما بنقدر نحن نشتغلها. فرح نوقف انه اذا عطتنا 1 or 2. بس انا ما بقدر اعرف 1 2 او 3 او 4 interception point unless you have to do it. You have to draw this plot. بتكونوا اوقات عم تضيعوا وقتكم اذا ما قدرتوا تستعملوها. So you have these 4 methods. You can pick any one if I'm not asking you specifically to draw any specific type of plot or to calculate the value based on a specific type of plot. You can draw any of these 4 methods. أنا بنصحكم to avoid Cornish bounding لأنه ما بتعرفوا كيف حتطلع. ممكن تكونوا عم بتضيعوا وقتكم. Unless سألتكم to draw Cornish bounding plot you do it. إذا لا forget about it. استعملوا حيلا واحدة من الثلاثة اللي قبل. بس كمان الأسهل والمور common هي الدبل انفرس بلوت لنوفربرغ. أوقات أنا ما بجبركم بميثود. The best one or easiest هي to calculate 1 over v function 1 over s and do your plot based on double inverse plot أو Linover and Berg plot. اوكي بس ما هالشيء بيعني انه ما بنرسم ابدا ايدي هوفستي او هانس وولف او كورنيش باوندن. You have to know all these methods but it depends what we are asking you in the exam. Deal? Any question? Any question? مروان مبروك الايميل ظبط شكله.
يا دكتور غيرت لي المدام هبه. ايش الايكويشن تبعت كورنيش باوندن؟
هي ما في equation. انت في as function of minus s. انت شايف التيبل اللي عندك هي هون view s؟
يس.
انت ما عم ترسم بلوت. انت كل 2 فاليو يعني حسب عندك انت هون v وهون s وهيدا هون minus s. بتقول for v equal هالقد minus s equal هالقد توصلهم ب straight line واحده.
اوكي
انا انتبهوا انا اوقات بلاحظ طلاب شو بيعملوا بيقولوا v minus s بحطوا النقطه هون بالنص. تطلع عندهم بلا ما تطلع v as function of s hyperbolic هون عم تطلع v minus s بالمقلوب which is wrong. انا ما عم باخذ a point on the plot. انا عم باخذ couple vs وارسم لهم straight line. ما عم باخذ for v1 و s1 وحط نقطه بالنص لارسم plot v as function of s. فهمتوا علي الفكره شباب صبايا؟ ليش ساكتين؟ ما حدا عمل كومنت.
يس دكتور فهمنا.
So it's not a plot v minus s بس هي different several straight line, the interception point will give you the value for Vmax and Km. Sometimes you have just one interception point. احنا هنعمل limit ل 2 interception point where you take the mean between Vmax and Vmax1, Vmax2, Km1, Km2 وبس. إذا أكتر ما تعذبوا حالكم إنكم تشتغلوا الكيس. روحوا ارسموا غير رسم، غير method. So هيك بنكون خلصنا chapter 3. It's based on Michaelis-Menten. What are the different kinetic parameters and how we can determine these parameters using Michaelis-Menten equation or Michaelis-Menten plot or the different type of plots. Double inverse plot, which is the Lenover-Burr, Eddie-Hofstee, Hans-Wolf, or Cornish-Boundary. Now we have a revision about all this information in these questions. You have one or more answer correct. We will start with the first question. واللي بده يجاوب يرفع ايده please. The initial velocity of an enzyme catalyzed reaction could be. نعم. مهدي؟
بس كان عندي سؤال عن قبل بس بليز قبل ما بس لأنه الكونكشن راح عندي كتير بدي أتأكد من شغلة.
تفضل قبل ما ترجع تروح.
اوكي بس لما كنت عم تحكي عن البلوتينج للبوينتس، يعني انا باخد كل في وكل اس بحطهم بايكويشن لستريت لاين برسمه وبرجع بنتقل عن اللي بعده.
صح.
شو اسمه؟
يعني بتوصل specific v specific minus s بستريت لاين واحد.
اوكي بس كان بدي اتاكد. شكرا.
اوكي. Yeah. So the initial velocity of enzyme catalyzed reaction could be determined after drawing what? Product as function of enzyme concentration, 1 over V as function 1 over S, product as function of time, or none of the above. هلا حاخد بالدور اللي رافعين ايديهم بدهم يجاوبوني كذا سؤال. حنمشي بنسرين جوني. تفضلي.
Yes, doctor. The answer is C, product as function of time. We draw the concentration of product as function of time.
And how you can calculate the V0 in this case? It's what?
V0 equal Km concentration.
طيب بس رسمتي product as function of time. كيف بتجيبي؟ عم نقول the initial velocity of an enzyme catalyzed reaction is determined after drawing P as function of time. صح؟ رسمتي product as function of time. كيف بتجيب ال V0? It's what? إذا جاوبتي وما بتعرفي كيف يعني في مشكل.
لا صراحة.
طيب ليا كيف بنجيبها لل
Doctor,
ترسم product as function of time?
we draw a tangent and calculate the slope. It's the slope of tangent.
Tangent at where? At time equal to?
At the time equal 0.
0. So you draw the tangent on this plot at time equal to 0, and you determine the slope for this plot, and this slope is the value of V0. Okay. Lana Awala. Next. The initial velocity of an enzyme catalyzed reaction is determined from the plot using the slope of. هلا جاوبنا.
Yes, the tangent at t equals 0 minutes.
Tangent at time t equal to 0. ما هحسب لك هالسؤال لأنه هلا جاوبنا. جاوبينا على هذا السؤال. The initial velocity of an enzyme catalyzed reaction depends directly on
the enzyme substrate complex concentration.
So the enzyme concentration alone, the substrate concentration alone, or the ES complex alone. Why? Correct.
Because ممكن نحن اللي يكون عن ال ES complex.
كثير سهل.
Because of no
because شيء محدد. ترى جنيدة أو جنيدي.
Because V0 equal K catalytic times concentration of the S complex.
برافو عليك. ها هي. فهمتي علي نسرين يمكن اللي كانت قبل؟
لا أنا دكتور.
مين أنت؟
لانو.
أنا ما بحفظ أسماء
لانو.
كتير. Okay, so V0 he directly proportional to the enzyme concentration, enzyme substrate complex concentration, because V0 is equal K catalytic multiplied by ES. دغري. Okay?
Okay, doctor. Yeah. Thank you.
When substrate concentration increase, the affinity of the substrate to the enzyme increase, the initial velocity of the reaction increase, the initial velocity of the reaction decrease, or none of the above. نسأل. ما في حدا رافع ايده الا نسرين. نزلتها كمان. يلا.
لا دكتور كنت رفعتها من السؤال اللي قبل نسيتها بس بجاوب ما عندي مشكل.
أنا ميليا خلي ميليا تجاوب حدا جديد. يلا ميليا.
The initial velocity increase.
The initial velocity increase. برافو. Next, Michaelis-Menten equation helps to calculate the initial velocity of the reaction if you know what? If you know the enzyme concentration, if you know the substrate concentration, or if you know both enzyme and substrate concentration. وبنسأل هالسؤال مهدي.
both لازم.
ليش؟ Michaelis-Menten equation شو هي؟ V0 equal قد ايه؟
Michaelis-Menten equation. بعدني ما حفظتها صراحة. V0 equal VM على times the initial. sorry.
V0 equal
V maximum.
نعم.
times ال S.
S.
concentration لل S over Km plus S over concentration plus the concentration.
Plus S. So V0 equal V max by S.
V max.
over Km
yes.
plus S.
فلازم يكونوا both اللي معي اياهم لحتى اقدر اطلع
بس هي if you know S concentration ما شفت انا بالايكويشن الا V max و Km معك S، لانه اذا انت اذا معك السبستريت concentration بتقدر تجيب الفي 0 لانه هي في ماكس، لانه Km و في ماكس هن specific parameter للانزيم، بكفي انه يكون معك ال S concentration to determine the initial velocity of the reaction based on Michaelis-Menten equation.
راح فكري على الجراف انا على البلوت. اوكي.
هلا ممكن هون حدا يقول لي طب ما هي في ماكس هي كي كاتاليتيك باي اي توتال، يعني بدي الانزيم كونسنتريشن. اوكي بس هون نحن السؤال اكثر موجه انه اذا معنا الكي ام وفي ماكس للانزيم شو بدنا لنجيب في Michaelis-Menten constant is the value of S which give an initial velocity equal to 1 over 10 Vmax, 1 over 2 Vmax, equal to Vmax or equal to 1 over 2 Km. وبنسأل حدا جديد محمد فرحات.
half Vmax.
1 over 2 Vmax. So when S equal to half Vmax, when V0 equal to half Vmax, S equal to Km. صح. The Michaelis-Menten equation, which is V0 equal Vmax by S over Km plus S. When you draw this plot اللي طلعت معكم بهالصورة, you have to fill in the blank, which with the letters show the correctly label each part of the graph. So you have A, B, C, D, and E. And the parameters are Vmax, S, V0, point used to determine Km and Vmax over 2. لنشوف مين في عنا حدا جديد رافع ايده. ليا سري الدين.
Yes doctor.
يلا.
ال Vmax هو ال D.
Vmax هو ال D.
ال S هي ال B.
S هي B. صح.
ال V naught هي ال C.
اوكي كفي. What is the point used to determine Km?
KM لحظة الفي نوت هي الإي.
اوكي هلا ظبطتيها.
Yes, and the point used to determine the Km is C, and the Vmax over 2 is A.
So D is Vmax, so you are drawing E as function of P and V0 as function of S. D is the value that represent maximum velocity. A هي Vmax over 2, and C is the value that will help you to determine the value of K.
Yes.
Often the kinetic value of an enzyme are plotted using the Lenover-Burke equation, which is 1 over V equal Km over Vmax multiplied by 1 over S plus 1 over Vmax. You have to enter yes or no to indicate if the equation and graphical terms match in each statement. So just you have to put yes or no. And for this question, I will ask Ruba.
Yes, doctor.
تفضلي.
The first one is no.
Y-intercept and 1 minus 1 over Km. No?
No. Y-intercept is 1 over Vmax.
Okay. So X-intercept with 1 over Vmax, is it correct?
Is also no, it's also no.
Okay. Is the slope equal to Km over Vmax?
Yes.
Okay. So Y-intercept was 1 over Vmax, X-intercept was minus 1 over Km, but the slope is correct, Km over Vmax. هيك بنكون خلصنا هول revision questions. Do you have any question or any comment or any?
دكتور
Yes.
حنعمل applications عليهم للجراف انه كيف نرسم ونطبق عليهم exercise. Yes, okay. Thank you.
وهلا جاي اقول لك يا دموزيل لو ما حكيتي كنت وصلك الجواب دغري. It's exactly what I am doing now. يا حلوين. الاكسرسايز بتفتحوا على الاكسرسايز بالتيم. انتوا هلا شو مبين عندكم على الصوره؟ chapter nomenclature chapter 3 enzyme kinetics.
هلا nomenclature.
Okay. So now you can start with exercise chapter 1 and chapter 3. هيك خلصناهم and you can start doing these exercises for chapter 1, which is enzyme nomenclature. You have different questions regarding the classes of enzyme. And for chapter 3, you have also different exercises regarding Michaelis-Menten equation, the initial velocity, and how to draw V as function of S or 1 over V function 1 over S, etc. So you have a series of exercises for chapter 1 and chapter 3. You can start preparing them to do it, maybe starting next week. Okay, so this week I will continue with the course, but starting next week you can start solving some exercises, specifically chapter 1 and chapter 3. يعني أكيد next Monday أنا بدي أشتغل exercise. شباب صبايا
Yes,
ليه
doctor.
بتكون اوقات بتختفوا مثل كأنه ما بقى موجودين. الو يا حلوين.
Yes, doctor.
فهمتوا انه next Monday بدنا نحل exercise chapter 1 and chapter 3؟
Yes.
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 يس دكتور.
اوكي. هذا اللي بدي اوصلكم اياه. بكره انا حوقف اليوم هون لانه صاروا معلومات كتار. بركي باليوم بتبلشوا هيك شوي تتسلوا بالاكسرسايز 1 and 3، بس بكره بدنا نبلش تشابتر جديد، فبفضل بكره نبلش فريش with a new chapter.
دكتور بس بعد ما بينوا بالتيمز بالاكسرسايزز.
بلا موجودين لازم يكونوا دوموزيل. حطيت كل
ايه
شيء
ما
انا
هلا
على
صرت
التيم.
قريته كذا مرة ما بينوا عندي.
exercise
هلا
الانزيم
بعد بس تخلص ايه ما طلعوا عندي. هلا بس تخلص الحصة برجع بعمل ريفرش اكيد حيبينوا.
لا ما هو
وعندي كمان ما بين.
ريفرش دوموزيل انا منزلهم من اول بس تفوتوا على الفايلز في عندكم كورس ليكتشرز بتشوفوا كل الليكتشر، في عندكم فايل اسمه exercises بس تفوتوا
يس
على
عندي
دكتور
كمان
هذا الفايل فاضي.
بس فاضي الفايل.
مظبوط. اوكي هلا برجع بحطهم، انا حاططهم قبل. I will put them again today. منيح اللي قلتوا لي. يلا هلا
اوكي دكتور
ححطهم.
ثانك يو.
يلا نو بروبلم. اليوم حتلاقون. اوكي هلا دغري بخلص الليكتشر وححطهم.
اوكي دكتور.
Any other question؟
Doctor, I have a question.
تفضلي.
هلا if they give us a question and we have to draw a graph, we do the entire derivation of Michaelis-Menten, then we use on it.
When they ask you to draw a plot, you draw it directly. When they ask you to calculate values from the plot, you calculate directly. When they ask you specific question regarding derivation, you have to do it.
Okay. كمان regarding the other plots.
مش كل مرة بكون ترسموا بكون تعملوا derivation. إذا انسألتوا تعملوا derivation بتعملوها.
With other plots كمان do we have to يعني to write first Michaelis-Menten then
لا يعني بيقولوا لكم based on which plot you have to draw. يعني إذا ما سألوا ما طلبوا منكم ترسموا شيء ما بترسموا.
I know بس إذا ما
إذا سألتوا ترسموا مثلا ادي هفتي بترسموا ادي هفتي، ما اعطوكم ترسموا شيء معين، انتم حرين ترسموا حيلا ميثودز من الاربعه اللي علمناكم اياهم.
اوكي بس لازم نكتب دغري الميثود ولا بنعمل ميكايلس-منتن وبنظبطها لحتى تصير مثلا لين ويفر بلوت
لا فيك ترسميها دغري دوموزيل وتكوني حافظه الايكويشن.
هي قصدي انه بنكتبها دغري حافظ الايكويشن.
صح. وفيكي اذا ممكن انت اجباري اذا بتنسي الايكويشن وعارفه كيف لازم تعرفي كيف تجيبيها، بحال نسيت الايكويشن تكوني عارفه كيف تجيبيها وما تضيعي علامات.
اوكي. Okay, thank you.
Other questions? Okay. Yeah, have a nice day and we'll see you tomorrow.
Thanks, doctor.
أهلا.